Yeah, good morning guys.
Good morning.
Yeah, why we are here?
Case study on
Yes, case study on PCB. Yes. So far we have discussed many input-output devices in our embedded system design, which is integrated and incorporated with the CPU, right? So PCA is also a major device which is connected with our embedded system, that too with your CPU. So we also have local computers, right? So the major role of this PCU is to, what is it? To connect with, it is a hardware, right? So it is used to connect with hardware parts in a computer. It is used to connect with the hardware part in a computer. So what is that hardware description languages we have discussed, right? So we have a separate software tools and we have separate hardware devices. So if we want to get results in a simulation, what we will do, we can download the details from hardware to software using these devices like PCA, FPGA. These are all devices which can convert, which can download the device results from hardware into a software simulation. So this PCA plays a major role in local computers to connect with hardware units. Am I right? Yes, now come with your views.
Firstly, we are going to discuss about PCI. PCI means Peripheral Component Interconnect, which is a high-speed parallel bus standard. It is used to connect the hardwares like network cards and graphic cards with the processor. Secondly, this PCIs are replaced by the PCIe, which is Component Interconnect Express, which is more advanced than PCI, used in legacy systems and embedded systems. The history of PCIs comes from firstly Intel is introduced the PCI. Next, PCI 2.0, which is gives a plug and play compatibility. Finally, it is moved to the advanced level, which is PCIe. Through the serial communication, the PCI is advanced to high speed and for many applications.
That's good.
So let me share a few points about the working of the PCI. So first, in the PCI slots, the outer devices are connected, the peripheral devices are connected, and the first step is that the controller scans the PCI slots, whether how many devices are connected and how they are connected and what are the devices connected. And secondly, the device sends a request to the controller for accessing the data transfer, and the controller responds it with a data transfer connection permission and grants the permission. And thirdly, there will be a data transfer for which the device is connected, and it happens with the direct memory access, and the memory is sent from the direct memory access. And the fourth step is that after completing the process, it sends an interrupt that sending a notification that the process is complete, and this happens in the working of PCA.
So as the types of PCA as united, some of these are conventional PCAs, which are standard parallel PCAs for used for 32 bits and 64 bits. Then PCIX is enhanced with higher bandwidth, which is used for the servers. Then mini PCAs are included in mini versions that can be used in laptops, phones, and embedded systems. Then also PCI Express is used in the industrial sites and IoTs. Then PCI Expresses, mini PCI Expresses are used for the enhancement of the overall technologies with the serial communications.
I am going to tell about the advantages and disadvantages of PCI. First, the advantages of PCI. It is a high-speed data transfer place, and then it supports the plug and play support, and then it is scalable because it is connected to multiple devices in the same bus. And then the third part is it is bus mastering, so we can send the bi-parallel. And then the disadvantages of PCI are the disadvantages are limited bandwidth, parallel bus issue, and then it cannot work on modern AI and ML workout capabilities.
I think now we have a clear idea about PCA, right? So it plays a major role in our embedded system design. So embedded, since the main meaning of embedded system is it is an inbuilt device. So PCA is an inbuilt which supports all the CPUs, all type of CPUs, including your local computers. Okay. Yes. Thank you all.
Thank you.